Alright, welcome back to my daily Leetcode problem, and another day, another problem, and today is my 90 day of Leetcode commitment and we are hit by the heart. So the Leetcode problem is the longest common service query. We are given a two array of string, what container and what query. So let's go to the SQL draw so that we could have a better understanding. So for each query in the index, we need to find the string from the what container, which is a large one that has a longest common suffix. That means, which is a suffix, mean we need to compare each of the string that has matched with the suffix from the what query. So if there are two or more string in the what container, so that share the longest common suffix, we have to find the string that is smallest in length. So okay, we don't know what is that. If there are two or more string that have the same smallest length, we need to find that one occurred earlier in the word container. Alright, let's try to understand what they want from our solution. We have to return an array of integer answer where each index of the answer array is the integer of the string in the word container that has the longest common suffix with the word query index. So let's go with the HTML one, which is a CT. So we have a lot of options in here. So if I mention by the CD, so we can think of it like we can see the CD in here. We can also see the CD in here. We can even also see the CD in here. But there's a one clause mentioned above. If there's a two or more string in the word container that share the longest common suffix, we have to find the string that is smallest in length, which is the BCD, because the count of the BCD is only 3. So we just return the index 1 for the index 0 of our answer. Alright, that's for the CD. How about the BCD? So if I have to mention the BCD, so BCD could be seen in the 3 places, the same as the previous clause in here. So we have to find the string that has the smallest in length, so which is BCD, so we return the index 1. How about XYZ? So when it comes to the XYZ, we cannot find anything that has never appeared in our word container. So if there's a two or more such string that has the smaller length, so we have to find the occur earlier in the word container. What is occurred before? That is index 1. So that is the reason why we return the index 1 in here. So if you read through it, if there is no string for the word container that share the common suffix, hence the longest common suffix of empty. So we need to keep in mind that if there is nothing much, we are trying to compare with the empty string that is shared with the 0, 1, 2. Among these answers, the string at the index 1 is the shortest, so we choose the length of 3. So we got 111 as answer for HTML 1. How about HTML 2? We have an input container of 3 input and then 3 word query, which is GH. And GH could be seen in 3 places, GH, GH, and GH. If we have to count manually, there's only 6 character in the index 2, and there is 7 character in the index 1, and there is 8 character in the index 0. That's why we choose the index 2 as our answer for the index 1. How about the second one, ACB FGH? What could we find? We can find the FGH in here, ABC in here. We can find the GH in here. We can find the GH in here. So we have to choose the longest common suffix query. That's why we choose the index 0, which is the ABC. So that's why we return the index 0 in here. How about the third one, ABC FEGH? So we have ABC in here. Okay, my bad, it's not ABC, it's ACB. Alright, so I think I make a mistake here. So ACB have not matched with any of those in the XML 2 of index 1. Let's go through again FGH, GH and GH. So we choose the FGH, which is 0 in here. Okay, how about XML 2 index 2? So we have ACB, FEGH. ACB is nowhere else, and GH is the only option, I would say, because we're gonna find like BF or BC or CB. So GH, so that would be GH, GH, and GH. So we choose the shorter one, which is the index 2. So we return it here. Right, that is what we wish. And we have to see the constraint also. So we can mention that the character will only include the lowercase English letter, and the word query will also only include the lowercase English letter. So the sum of the word container index length is 500,000. Yep, the same for the word query. So there is one data structure I would like to introduce before we solve this problem. That is called try node. So what do I mean by try node? So we gonna create the node, something like a linked list, but which is not linked list. Let's consider we have two words in here, cat and car. I'm gonna put the C in here. So which will be A will be here. So we got C to A in here. And if we have to create remaining of the value, so what we are going to do is we're going to create the two more nodes, which is T and R. So that is what I would like to do in our problem, and that is the data structure we should use, because that will help us to navigate easily through the problem. So in here also, that will be much easier if we reverse the word query. Instead of CD, how about we use the DC, and we will reverse everything in the word container and word query. Alright, so after we reverse it, we're gonna put it in the try node, and which will help us to easily search that is this a cat or is this a car, like this. So that is inappropriate drawing, but we're gonna deal with that. And then let's start write some of the code. So about the data structure that I would like to use is called try node, and it's going to have like things called children. So in children, I would like to have key as a character, and the value will be the try node. And then I'm gonna put the empty. What I want to do is we need to keep track of the index for this, and then I will put the best as a -1 at first, since nothing is going to extend our try node. I'm gonna keep safety as a final class, so nobody will come and change our class. To the string indices, we will use the thing called result, which is given here, and I'm gonna return the result in here. And I would like to run through like in the query in what's query. So when we are going through the query, we need to split down into the smaller pieces of character. Let's call query will be the array of query dot reverse. So as I mentioned before, if we reverse all the inputs of the query and container, that will be easier as to solve this problem. And we need to start using of the try node in here. Let's call root, which is a try node we will declare initially. And I'm gonna put the node as a root, and then we can go through each character in query. Let's consider that we have a what's come in like a CD and BCD and XYZ. In here, that will split into the D, C, and it will be like D, C, and B. And another will be the Z, and Y, and X. Cool. So we got what we have, and I want to check like our next node should have a value which is called children. It exists in our character. If not, I'm gonna break the loop and I will update the node with the next node here. And then I can just append to the reset, which is going to be the node of best index. But before that, we need to prepare something else for our data structure, because we only have reverse to the word query and we still need to take care of the word container. Let's call like container count, which is going to be the what's container.count, and I'm gonna run through the for index in 0 through container count, and we need to find which one is better. Like when it's come to the to length, how about we create the inner function? Let's call it better. That will be the new index and old index. I'm going to compare these two, and I will return the boolean. So to compare the which one is better, we will check like if old index, which is going to compare in here, the best index is -1, we will just return true, because we are pretty sure like even though if the old index is -1, we just need to return the true because we don't need to compare it, because that is totally the new index. And we need to calculate the new length of each character coming through this word container. Let's call like if the new length of what's container of new index dot count, and we will also need the old length because we need to compare the between old and new, and then we're gonna pick up the shorter count of the string index. So let's go old index will be the what's container of old index count, and we're gonna compare like if these two lengths are not equal for sure, because if it is equal, that is going to be the problem for us. And if it is same, I will return new length is less than to the old length. So if old length is greater than the new length, we just need to return the true. If not, we return reverse. Let's go new index or old index. So which is technically given in the here. I'm just trying trying to translate the question into the code. And we also need to find the best, because even though we know which one is better, we don't know which is the best option for us. So to choose the better option and the best, let's call like update the best, which is going to use a thing called note, because we are using the trial note in here, and index will be the integer. So that's technically just a two helper function we need, and we'll check like it's better of the index and note of best index, which is O index, and we're gonna update the note of best index with the index. So you guys might have a question. Even though the variable of the node is not in our, how come we can edit the node? Because this is a class, it's a reference type, and we have variable which is can be changed because we're using the var and not a constant. So after going through that, we can come back to our main business, which is calculation of the coordinate count. So I'm gonna use update best using the root, which is the root in here, and then we also need the index, which is going to be the index from the our container. And then I'm gonna reverse the words, because even though we got the words called what container of index dot reverse. So after we reverse the container count of here, so we are going to receive in like something like this, D, C, and B, and A. All right. So after we reverse through it, we need to update our node, which is going to be the root. So that's quite similar with the approach from the below. So we just want to do the same. Let's call like character in words instead of query, because this is using the word container, not the query container. And each word, I'm going to check node dot children. Children of character. So I'm going to check like the next character is nil, which is we set in here. I'm gonna put the note with the new children, because so when it come back to here, we are in the let's go like R. We check they have children or not by checking it is nil. If it is nil, we're gonna put the our character with the try note, and then I'm gonna update the note of children with the character, and then I will just update the best using the node and index. Yeah, I think that's pretty much for it. So I can show like what is the data structure that I am preparing before all of these stuff. Let's go print out the node. Let's try to run through it locally first. I might encounter the problem as I expected, because every time I write the more code I wrote, I might face the more typo issue. Alright, cool. So in here, if we okay, that is a terrible idea. I might need to dump it instead of print. Alright, cool. Okay, that would be a little bit difficult to understand, but this is much better instead of the previous one. And so we have things comes to the our inputs with, as we expected, DCBA. So we put the D, change the C, and then change the B. Yep. And then these have to change. After that, we have a thing called X. Alright, so we are technically mapping in here. So for the better understanding, I can show what I was done in the past in the code. So let's write that down. We are reverse everything in here. So DCBA and DCB and DCBX. So as I mentioned here before, we have a thing called D in here and C, of course, and we have a thing called B, and I'm gonna map it, and H and A, something like that. So like this. Oops, not like this. Why is this so ugly? I'm gonna update my arrow using this. Alright, cool. So we have received this thing, DCBA. So as I expected, DCB and H and A. So after we set up properly, every time we want to search through it, we can easily navigate using finding the best. So after that, we will root through it and then append our index using the best index. So best index means that is keep track of the index of these each index. What I mean by best index is, let's consider we have 3D in here. The index of this one will be the 1 because the best is here. Alright, let's try to submit and see our space and time complexity. I hope I didn't face the time limit AC. Why? Because I'm damming it. Silly me. Let's submit again. Sometimes a small print could crash in the Leetcode, but not in the HackerRank. Alright, let's try to analyze our time and space complexity. So the time complexity that I was expecting is O of n, O of length of container and query, because we use a combination of container and query, and for the memory that will be the length of character multiplied by 26, because we have limited to the only lowercase character according to the constraint. Yep, I think the video is a little bit long, and hope you guys enjoy the video, and then see you in the next one. I don't know why it is not refreshing. Oh gosh, not sure I'm late to submit, or let me refresh for the one last time. Cool, we are good to go, and 2 more days to make our habit strong and tight. See you in the next one. Bye.